I'm going to make a prediction. Before this video is over, I sneeze more than once. Let's see what happens. Okay, so now we're going to work on getting volumes of pyramids and cones. In the previous video, we talked about how to get the volume of prisms and cylinders. The idea was that you just get the area of the base and multiply by the height, thinking of the prism as just layers of that same base, or thinking of the cylinder as layers of that same circle, so the area of the circle times the height. Now, I tried to draw this pyramid so it looks like it has the same base as that prism and the same height as that prism. And if that's the case, it's actually deceptive. How do you think the volume of this compares to the volume of this? In other words, if I filled this up with water and dumped it into this, it would not fill it up. If they had the same base and the same height, it wouldn't fill it. But how high up do you think it would go? A quarter of the way, half of the way? And the answer is surprisingly only 1/3 of the way. Usually when I ask this in class, and I have a pyramid and a prism in class that I can hold and show you, most students guess that it's half, but it's actually 1/3. And the same is true down here. If I filled up this cone with water and dumped it into this corresponding cylinder with the same base and the same height, this would only fill up this 1/3 of the way. And the proofs of those are not at all easy, but I'm going to see if I can link a video in the description below here that shows that. It usually requires some animations to make it attainable. But anyway, what the end result is if the volume of a prism is area base times height, the volume of a cone is 1/3 area base height. And the same is true down here. The volume of a cylinder is area base height. Because 3 of these are needed to fill that, the volume of this is just 1/3 area base height. Now again, all of our cones are going to have circular bases. Technically, this is a cone. And again, I probably won't be drawing this very well, but see if you can get the idea of what I'm trying to draw. So some smooth curved base, every point on that base is connected to one vertex up above. So that shape is technically a cone. That's an awful picture, but we're only dealing with circular based cones. So the area of the base is always going to be for us pi r squared. So we can also think of it as 1/3 pi r squared h. But in terms of trying to remember them, I would just link these together. Cones and pyramids are 1/3 area base height. Okay, now some vocabulary. There are right solids and oblique solids. So if we think about cones, what it means to be a right cone is if the vertex is connected to the center of the circle inside, if that forms a right angle with the base, then that's said to be a right cone. In other words, the vertex point is directly above the center of that circle. But if it's like this, where here's a radius of the base and here's the vertex and I connect the center of that circle to the vertex, that's not a right angle, it's an oblique cone. The good news is the volume of this and the volume of this have the same formula. Whether it's a right cone or an oblique cone, it's going to be 1/3 area base height. So the same would be true with hexagons, or I'm sorry, with pyramids. If the center of the base connected to the vertex above forms a right angle with that base. So if this is perpendicular to that bottom surface, this is called a right pyramid. But if this vertex point were way over here or way over here and that didn't form a right angle, it'd be an oblique pyramid. But the formulas work the same way. The volume of this pyramid is 1/3 area base height. One more bit of vocabulary. I do have three examples to show you. Dealing with pyramids and cones, there are 2 different types of height to be aware of. The height that's referred to in the formula is this: the distance from the vertex to the base such that it's perpendicular to the base. So this is what we mean by height. But there's another one called the slant height. which you'll be seeing. So if I connect the vertex to this edge so that it makes a right angle, and that would look like this. So this is on the surface of the pyramid instead of inside the pyramid. This red segment is called the slant height, usually abbreviated with the letter L. And what it's defined to mean is, if you imagine if we could pull this triangular surface off the pyramid, that red segment would be the height of that triangle, right? Going back to the last chapter, 1/2 base times height for the area. This is the height of that singular triangle, but it's called the slant height of the pyramid. And the reason, and the same is true for cones, by the way. This is the height of the cone. This is the slant height of the cone. So usually, again, abbreviated with L. This is the one used in the formula, 1/3 area base times this height. But here's why I mentioned the slant height. I'm going to try to remember to link a PDF of this handout in the notes below as well. A lot of times, the height that you need is not given in the problem, and you have to somehow figure it out. So there are 3 hidden right triangles in pyramids that you need to be aware of, and I tried to draw them out here for you. This is the most common one I think we'll be seeing. Sometimes you don't know the height of the pyramid and you need to figure it out. But if you know the apothem of the base, so thinking back to that last chapter, the apothem of a regular polygon goes from the center to the side, making a right angle. If you know the apothem and if you know the slant height, those 2 sides with the height form a right triangle, and you could do the Pythagorean theorem to get that missing height. Here's another right triangle to be aware of. Sometimes you'll know the slant height and you'll know this lateral edge. And if you know those 2, then you could do a Pythagorean theorem to figure out how long this is. And once you know this, you can double it and you get a length of the side of the base. Here's one more right triangle to be aware of. The radius of the base, thinking back to that last chapter, radius of a regular polygon, the lateral edge and the height also form a right triangle. And if you know 2 of those 3 sides, the Pythagorean theorem will get you the missing one. So this is a handout I normally give out in class, and again, I'll link a copy of it to the video below. So let's get to the 3 problems. Number 1. While I go get a tissue, I'm going to cross in front of the camera here. Get a good shot of that. Here I come again. All right. I'm assuming you paused the video and gave this a shot. Were you able to figure out the volume of the cone? So here's how we would do it. Volume of a cone is 1/3 area base height, and again the base is a circle, so pi r squared is the base. So the numbers we need are the radius and the height. Well, the radius must be 10 if the diameter is shown to be 20. We were given the slant height of 26. Remember, we need the height. And since the problem says it's a right cone, we know if we connect the vertex to that center point, we're going to have a right angle. So Pythagorean theorem, 10 squared plus the height squared equals 26 squared, and that's going to come out to be 24. So that's the height we want to use, not the slant height. So the radius is 10, the height is 24, 10 squared is 100, times 24 is 2400, times a third is 800. The exact answer is 800 pi feet cubed. Here's a second one. What is the volume of this regular pyramid? Now I should explain, regular pyramid means that it is a right pyramid for starters. So if we connect that vertex to the center of the base, it's going to be a right angle. It's not one of those oblique, sort of slanted pyramids. But it also means the base is a regular polygon. So that's important. So we know that this four-sided base, if it's a regular quadrilateral, that would be equilateral, equiangular, so that base is a square. So see if you can figure out the volume. Here we go. You'll notice the area of the base I changed to s squared on this one, because the base is a square, and that's the formula for the area of a square. But we need to know the height, so I'm going to draw the height. So here's this right triangle that I mentioned over here. Let's see if we can get all this in the shot. So I'm using this right triangle inside the pyramid, because we know the slant height is 13, and we can figure out what the apothem is. The best tip I can give you with working on these is to draw the base by itself two-dimensionally. So what I would do on this is I would draw the square as though I was looking at it directly. And in order to figure out the apothem now on a square, it's not too difficult, but this applies to all of them. I would do this. I need to know that apothem. It makes a right angle. So this is just like we did it in the last chapter when we did regular polygon area. So the radius bisects the angle, so I get a 45-degree angle. So it's a 45, 45, 90. If this is 5, half of the 10, then I know that this side of the 45, 45, 90 is also 5. So the apothem is 5. That's this. So Pythagorean theorem, 5 squared plus the height squared equals 13 squared. The height must be 12. That's where this 12 came from. So the work on these is going to be in finding the numbers that you need to plug in. And these triangles are going to help you with that. Okay, last one. This one's a tough one. And I'm going to have my videographer give you a nice shot of that. She stepped away to get me a tissue. I haven't sneezed yet. I might be wrong here. Do we know how to edit in a sneeze? All right, regular pyramid. So that's telling you that base is a regular polygon. So what's the volume if the radius of the base is 11 and this lateral edge is 19? Nearest hundredths for this one. All right. So let's see. Volume of a pyramid is 1/3 area base height. In this case, the base is not a square like the previous one. It's not a circle like the first one. It's a regular pentagon. So the formula for that is half AP. So by writing it out this way, I know the numbers I need to find are the apothem of the base, the perimeter of the base, and the height of the pyramid. None of which were given. So that's a lot of work to do. And remember, I said if you're stuck on these, the best tip I can give you is draw the base as though you're looking at it directly. So I drew this pentagon as though I were looking just at the bottom of the pyramid, a regular pentagon. And just like in the last chapter, draw the apothem and the radius. I used my n-2 times 180 formula to figure out that these angles are each going to be 108 degrees. The radius bisects this 108, so that's a 54. And if that's 90, that's 36. And I needed to get the apothem, and I also needed to get this side. So I did A for apothem and X for this side. So starting with the apothem, I have to use my trigonometry. This is not a special right triangle. I chose an acute angle, and I needed the opposite leg, and I knew the hypotenuse. So I wrote a sine equation. Sine of 54 is the opposite over the hypotenuse. Multiply both sides by 11, there's my apothem. Notice I didn't round it off, or only rounding off the final answer, because the direction said to round off. Sine of 36 is going to be x over 11, opposite over hypotenuse. So multiply both sides by 11 to solve for x. All right, now x is 11 sine of 36 then this whole side would be double that, which is 22 sine of 36. And then I multiply by 5 to get the perimeter, 110 times the sine of 36 degrees. All right. So now I've got those numbers. I've got my perimeter. I got that number. I got the apothem. I still need the height of the pyramid. Let's go back to the original picture here. Here's the height of the pyramid that we need. And the number we were given of 11 is the radius. So I'm going to draw a radius of 11. So here I'm using this right triangle. The one formed by a radius, a height, and a lateral edge, because I knew 2 out of these 3 numbers. So the Pythagorean theorem is going to get me the third one. So over here I did height squared plus 11 squared equals 19 squared. H squared plus 11 squared equals 19 squared. And my height came out to be 4 root 15. So now that I have all the numbers I need, I got my apothem, I've got my perimeter, I've got my height. I filled them in, the apothem, perimeter, and height. There's my apothem, there's my perimeter, there's my height. I grab my calculator, type it all in, being careful with parentheses. 1485.65 centimeters cubed. That was a hard one. I might have to watch that one more than once. So I'm going to sign off, but first let me say, achoo, achoo!